What if I told you that some of the greatest breakthroughs in modern medicine were not born in laboratories, but sprang from leaves, bark, roots, and seeds? Medicines that revolutionized heart disease, cancer, pain relief, contraception, and even the way our brains work were distilled from wild plants that humans have chewed, brewed, and worshipped for millennia. You probably have some of them in your backyard, yet the extraordinary stories behind them are rarely taught. While drugs like aspirin and metformin sit in medicine cabinets around the world, few people know that they owe their existence to willow trees and a scraggly European weed. And while potent chemotherapy agents and life-saving heart drugs trace their origins to obscure tropical shrubs and poisonous flowers, most doctors and patients remain unaware of the botanical adventures that made them possible. Today, I'm counting down 20 medical discoveries that came directly from plants. These aren't folk remedies. They're the foundations of modern therapies. We'll start with the familiar and end with discoveries so surprising they sound like fiction. Make sure you hit subscribe, because every week we explore secrets from nature's medicine chest that could change how you care for yourself and your family. Now, here are 20 plant-based breakthroughs, ranked from impressive to absolutely incredible. Number 1. Willow bark, the pain reliever that launched a pharmaceutical empire. Long before there were little white pills, healers from ancient Sumeria to Hippocrates, Greece, chewed on the bark of willow trees to treat pain and fever. That bitter bark contains salicylic acid, a compound that physicians have used for more than 4,000 years to ease rheumatic fever and colds. In the 19th century, chemists isolated salicin and learned how to transform it into acetyl salicylic acid, what we now call aspirin. Modern clinical studies proved that this natural product could relieve pain and inflammation and reduce fever, and it quickly became one of the most widely used drugs in history. Aspirin's ability to thin the blood has saved countless lives after heart attacks and strokes, yet its origins are purely botanical. Willow taught us that plant compounds could be modified to create safer, more effective drugs, setting the stage for the pharmaceutical industry. Number 2. Cinchona bark, the bitter cure for malaria. Malaria once decimated armies and empires, killing millions. Indigenous peoples in the Andes discovered that the bark of cinchona trees could stop the chills and fevers. In 1820, French chemists Pierre Pelletier and Joseph Caventou isolated the active alkaloid, naming it quinine. For generations, it remained the only effective anti-malarial and was shipped around the world. Soldiers in colonial wars and travelers in the tropics relied on quinine water, the bitter tonic that later inspired tonic water. Even today, quinine is used when modern drugs fail. This bark taught scientists how a single molecule from a tree could transform global public health and inspired the search for new anti-malarials. Number 3. Artemisinin, a revolutionary answer to drug-resistant parasites. Centuries after cinchona, malaria parasites began to outsmart quinine and chloroquine. During the Vietnam War, when soldiers were dying from drug-resistant malaria, Chinese scientists turned to traditional medicine. They screened an ancient fever remedy, sweet wormwood. In 1972, they isolated artemisinin from Artemisia annua and found it killed malaria parasites faster than anything else. Tests showed it was as effective as quinine and chloroquine, and combinations of artemisinin with other drugs are now frontline treatments across the world. This rescue story shows how centuries-old herbal lore and modern science can converge to fight evolving diseases. Number 4. Foxglove, the flower that steadies failing hearts. In 1785, an English physician named William Withering published his observations that extracts of the foxglove plant could slow a racing pulse and relieve dropsy, what we now call congestive heart failure. Foxglove contains cardiac glycosides such as digoxin and digitoxin. These compounds strengthen heart contractions and have been used to treat heart failure and certain arrhythmias for more than 2 centuries. They are potent, a little too much can be toxic, which is why modern digoxin tablets deliver carefully calibrated doses. Still, the fact that a garden flower could become a life-saving heart medicine underscored the medicinal power hidden in botanical poisons. Number 5. Opium poppy, the source of modern pain medicine. For thousands of years, people have harvested the milky latex from opium poppy seed pods to relieve pain and induce sleep. In 1803, German pharmacist Friedrich Sirturner isolated morphine, naming it after Morpheus, the god of dreams. Morphine was the first alkaloid extracted from any plant, allowing doctors to dose patients precisely and making pain management possible on a new scale. It remains a mainstay of severe pain therapy today. A few decades later, French chemist Pierre-Jean Robiquet isolated codeine, a milder opioid still used to suppress coughs and ease pain. These discoveries showed the power and peril of plant alkaloids, extraordinary pain relief tempered by dependence and overdose risks. Number 6. Rosy periwinkle, the tiny flower that fights childhood leukemia. In Madagascar, healers brewed tea from the rosy periwinkle to treat diabetes. When researchers tested it in the 1950s, they found it killed white blood cells. That could have been the end of the story, but a Canadian team realized this meant the plant might attack cancer. They isolated 2 alkaloids, vinblastine and vincristine. By the early 1960s, these drugs were saving children with acute lymphoblastic leukemia and patients with Hodgkin lymphoma, and they remain on the World Health Organization's essential medicines list. Without this humble flower, modern chemotherapy might look very different. Number 7. Pacific yew, the tree that taught us to tax cancer cells. In the 1960s, as part of a massive plant screening program, researchers collected bark from the Pacific yew tree. They isolated a crystalline compound and named it Taxol. It worked by freezing microtubules in place, preventing cell division and forcing cancer cells to self-destruct. The problem? Each tree yielded only tiny amounts, so making enough Taxol meant killing ancient yews. Demand skyrocketed after the drug showed promise against ovarian and breast cancer. Ultimately, scientists learned to cultivate Pacific yews and later to produce paclitaxel semi-synthetically from needles and twigs. Today, paclitaxel and related drugs are standard tools in oncology, all thanks to an obscure conifer. Number 8. American mayapple, the root of multiple cancer therapies. The Asian plant Podophyllum emoti and its American cousin Podophyllum peltidum contain podophyllitoxin, a powerful compound that disrupts cell division. Derivatives of this toxin, adiposide, teniposide, and adipophos, are used to treat small cell lung cancer, testicular cancer, leukemias, and certain brain tumors. They are also used in creams for warts and psoriasis, and even in anti-malarial drugs. Scientists originally relied on Asian podophyllum, but as supplies dwindled, they realized the American mayapple offered a sustainable source. Once again, a plant known as a garden curiosity turned out to be a pharmacological goldmine. Number 9. Chinese Camptotheca, unlocking DNA's Achilles heel. In 1966, researchers analyzing the bark of the Chinese happy tree, Camptotheca acuminata, isolated a compound that blocked topoisomerase Thwine, an enzyme essential for DNA replication. The drug, camptothecin, showed unique promise, but had solubility and toxicity issues. Persistent research yielded water-soluble analogs, topotecin and irinotecan, which gained FDA approval in the 1990s for ovarian, colorectal, and lung cancers. Camptothecin taught scientists that targeting DNA repair could kill tumor cells and opened a new class of chemotherapeutics. Number 10. Rauwolfia serpentina, the root that calmed the restless heart. For centuries, practitioners of Ayurvedic medicine in India used the snakeroot plant Rauwolfia serpentina to treat hypertension and insanity. In the 1950s, scientists isolated reserpine, the alkaloid responsible for lowering blood pressure, by depleting neurotransmitters. Reserpine became one of the first effective antihypertensive drugs, giving doctors a way to treat a condition that silently killed millions. Unfortunately, it also caused depression and other side effects, so it fell out of favor. But its discovery opened the door to modern blood pressure medications and psychotropic drugs. Reserpine also highlighted how traditional medicine can guide scientists to potent but complex compounds. Number 11. Deadly nightshade poison turned eye medicine and antidote. Atropa belladonna is infamous for its toxicity. Even small berries can be lethal. Yet, the same alkaloids that make it dangerous atropine and scopolamine have saved lives. Atropine dilates pupils during eye exams, treats slow heart rhythms, relaxes smooth muscles, and counters nerve agent poisoning. Scopolamine prevents motion sickness and reduces post-operative nausea. The dual nature of belladonna underscores the line between poison and medicine, and the skill needed to harness plant toxins for healing. Number 12. Ephedra, the ancient shrub that opened airways and noses. Species of ephedra have been used in China, India, and Tibet for thousands of years to treat asthma, bronchitis, and colds. The stems contain ephedrine and pseudoephedrine, sympathomimetic alkaloids that relax bronchial smooth muscle and constrict nasal blood vessels. For decades, ephedrine was a mainstay for asthma and low blood pressure, and pseudoephedrine remains in over-the-counter decongestants. Because ephedra products were abused for weight loss and athletic performance, many countries restricted them. But the medical value of these compounds, still derived in part from plants, remains unquestioned. Number 13. Autumn crocus, an ancient gout remedy that still works. References to Colchicum autumnale appear in Egyptian papyri from 1550 BC and in the writings of the Greek physician Dioscorides. The plant's toxic alkaloid, colchicine, relieves the pain and swelling of gout by disrupting microtubule formation and dampening inflammation. French chemists Pelletier and Caventot isolated colchicine in 1820, and a purified form was developed in 1833. Despite its toxicity, colchicine remains a standard treatment for acute gout attacks and is one of the oldest drugs still in use. It's also prescribed for familial Mediterranean fever and is being studied for heart disease and viral infections. That 3,000-year-old remedy remains relevant today attests to the enduring power of plant medicine. Number 14. Sweet clover moldy hay that inspired a blood thinner. In the 1920s, farmers noticed that cattle fed moldy sweet clover hay bled to death from minor injuries. Veterinarians traced the problem to coumarin in the clover, which mold transformed into a powerful anticoagulant. Researchers isolated this compound, named it decumarol, and eventually synthesized a series of analogs. One compound, number 42, would become known as warfarin, from the Wisconsin Alumni Research Foundation and the coumarin suffix. Initially marketed as rat poison, warfarin was approved for humans in the 1950s and became one of the most widely prescribed anticoagulants. It prevents deadly clots in patients with atrial fibrillation and after heart surgery. Thanks to spoiled hay and a plant's sweet smell, millions of lives have been saved. Number 15. Milk thistle, the liver's herbal guardian. The milk thistle plant, Silybum marianum, has spiky leaves veined with white. Dioscorides noted its healing properties nearly 2,000 years ago, and herbalists have praised it ever since. The active compounds, collectively called silymarin, are flavonoids found mainly in the seeds. They act as antioxidants, anti-inflammatories, and protectors of liver cells. In Germany, milk thistle is an approved herbal medicine for dyspepsia, cirrhosis, and liver damage from toxins. Intravenous silibinin, a component of silymarin, is used to treat poisonings from death cap mushrooms. Milk thistle is the most commonly used liver supplement in America, and research continues into its antiviral and antifibrotic potential. From hangover remedy to antidote, this humble thistle proves that gentle plants can have powerful effects. Number 16. Curare, from jungle poison to surgical tool. For centuries, indigenous peoples of the Amazon coated blow darts with curare to paralyze and kill prey. The resin, extracted from vines like Chondrodendron tomentosum, blocks neuromuscular transmission. In 1942, an anesthesiologist named Harold Griffith injected a synthetic preparation of curare into a patient undergoing appendectomy. For the first time, surgeons could relax muscles without deep anesthesia, ushering in modern surgical practice. Safer synthetic analogs quickly followed, but the concept of muscle relaxation during surgery began with a plant-derived arrow poison. Curare's journey from the rainforest to the operating theater is a reminder that even deadly toxins can become invaluable medicines. Number 17. Snowdrops and daffodils, unlocking memory in the brain. In the 1940s, Soviet scientists found unknown alkaloids in common snowdrops and red spider lilies. They named the major compound galanthamine. By 1960, they realized galanthamine inhibited acetylcholinesterase, increasing levels of the neurotransmitter acetylcholine. The drug was used for muscle diseases and reversal of anesthesia, and then forgotten. Decades later, when researchers sought treatments for Alzheimer's disease, galanthamine resurfaced. Extracting enough alkaloid from wild plants was difficult, so chemists turned to daffodil bulbs and eventually to full chemical synthesis. In 2000, galanthamine was approved in the United States and Europe for mild to moderate Alzheimer's disease. It now helps patients maintain cognitive function a bit longer. From snowdrop bulbs pushed through spring snow to pills that slow dementia, this drug embodies the long road from folk knowledge to modern therapy. Number 18. Dioscorea, the yam that made the pill possible. The Mexican yam, known as barbasco, looks unassuming, but its rhizomes are rich in diosgenin, a plant steroid. In the 1940s, American chemist Russell Marker sought a cheaper source of steroid hormones. Working with local guides in Veracruz, he harvested 10 tons of Dioscorea roots, extracted diosgenin, and converted it into progesterone using what became known as Marker's degradation. This process provided an affordable source of progesterone and other steroids like cortisone. In 1951, chemists Carl Djerassi, George Rosenkrantz, and Luis Miramontes used diosgenin as the starting point for synthesizing norethindrone, the first oral contraceptive. When the contraceptive pill was approved in the 1960s, it sparked a social revolution, giving women unprecedented control over their bodies and careers. The discovery of steroid sapogenins in an obscure jungle plant transformed both medicine and society. Number 19. Galanthamine repurposing a cholinesterase inhibitor for dementia. Galanthamine isn't the only plant alkaloid to influence neuroscience. After being isolated from Galanthus and Lycoris species in the 1940s and 1950s, this alkaloid demonstrated reversible inhibition of acetylcholinesterase and mild nicotinic receptor modulation. It was first used to treat myopathies and neuropathies under the trade name Nivolin. Because the plants contain only about 0.1% alkaloid, commercial supply was limited and expensive. Only after researchers developed extraction methods from daffodil bulbs and improved chemical synthesis did galanthamine become widely available. Its eventual approval for Alzheimer's disease in 2000 underscores the importance of persistence in developing plant-based drugs. Number 20. Goat's rue, the weed behind the most prescribed diabetes drug. Goat's rue, also called French lilac, was used as a herbal tea in medieval Europe to treat snake bites and plague. In the early 20th century, scientists discovered that it was rich in guanidine, a compound that lowers blood sugar in animals. Guanidine proved too toxic for patients, and interest waned. During World War II, researchers revisited guanidine derivatives and developed a biguanide called Metformin. First introduced in France in 1957, Metformin didn't win US approval until 1994. Today, it is the world's most prescribed drug for type 2 diabetes and is on the World Health Organization's essential medicines list. Yet few patients know that their tiny pills descend from a wild European plant, once dismissed as a weed. Number final reflections the green roots of modern medicine. Looking at this list, a pattern emerges. Curiosity about plants repeatedly pushed medicine forward. Bitter bark and pretty flowers became scaffolds for life-saving drugs. Poisonous vines and itchy shrubs yielded cures for cancer and hypertension. Even humble weeds provided blueprints for the most prescribed drugs on Earth. Many of these discoveries happened because scientists respected traditional knowledge and explored ethnobotanical clues. Others arose by accident, cattle bleeding from moldy hay, or a war driving desperate researchers back to herbal texts. In almost every case, the initial plant compounds were too toxic, too scarce, or too unstable for direct use. Chemists learned to isolate, modify, and synthesize them, turning nature's blueprints into modern therapies. And yet, these stories also reveal the fragile partnership between humans and plants. Entire species were endangered by overharvesting. Local knowledge was often overlooked, and economic forces sometimes delayed development for decades. As we confront new health challenges and antibiotic resistance, remembering that some of the most powerful medicines come from leaves and roots may guide us toward the next breakthrough. The next time you walk through a garden or forest, imagine the invisible pharmacy under your feet. Within those leaves could be the next cancer cure or the next life-saving drug. All we need is the curiosity to look and the wisdom to learn.